Okay, so in the earlier problem, we look at a model with months and late in it as separate predictors, but now we're looking at an interaction term between them. So what I'm going to do is insert an extra column, and often this is written as the first variable and then a multiplication sign and then the second one, and it's really just setting up the formula that happens, which is the first value times the second one. And we will just copy that down, and now we can run a regression where our net support will be our y variable here, and we'll grab all three of these right here as our x range. Notice it doesn't matter if we highlight top left to bottom right or vice versa, or even here to here. It just matters which cells get selected. I'm going to click OK and make that a little bigger here. Okay, so our model here starting to gain some terms, but the interpretation really isn't much different. So our predicted net support would be this negative 66.6283 plus number of months since, again, whatever that was, August 1975 or something, August 75, times this number, plus the late, which would be a 0,1 indicator variable, times this 13, plus this interaction term times 0.17398. And if you want to see how to write that out a little more formally, that's in the back of the book. You can check with the way the coefficients are written, but the entire model there is coming from this portion of the output. Okay, so did we need that interaction term? Was that giving us significant information over and above what we had before? If we take a look at, this is what the model looked like with the intercept, months, and late, but no interaction term. We can see our R squared there was 0.97, adjusted was 0.9, just a little bit lower. And then if we look here, again, we see an R squared just a tiny bit higher than it was before, and the same for adjusted R squared. So is that a significant change, that extra little boost we get by including the interaction term? Does that really help us describe the relationship between these variables and that net support better? Well, the null hypothesis, again, would be that the slope of this is equal to 0. And we test that here with our t-statistic, which would yield a p-value of 0.19, so on. That is not below 0.05, so we would fail to reject the null. So we really don't have evidence that this is adding significant predictive power to our model. So just to clarify what that would means we're probably going to go back to this model as our preferred model for the relationship, where we do have two parallel lines. This would have said that maybe the relationship, maybe the slope of the line would be different for the early phase than the late phase. And that could be true, but we don't really have substantial evidence to back that up. So this would probably be a pretty decent model for explaining that. I would like to add the number of data points here isn't ideal for running a regression with two predictors. Ideally, a rule of thumb is that you'd like to have 20 data points for each predictor in your model. That's a real crude rule of thumb, but I did want to point that out, that it is a little on the low side in terms of number of data points.